Okay, so topic for this video is going to be about surface area. And our essential question here that we're going to try to answer is, how is surface area calculated for three-dimensional solids? So a little background information here. It says total surface area is the measure of the total area of all of the outermost surfaces of a 3D solid. Lateral surface area is the measure of the total area of the lateral sides. Lateral surface area does not include the base or bases of a 3D solid, and surface area is measured in square units. My favorite way of thinking about surface area is like if you were going to wrap this thing in wrapping paper, how much wrapping paper would it take? Or how much paint would it take to cover the outermost sides of a shape? So essentially, if you found the area of all the different sides of this shape and you added them together, that's your surface area. We're going to start off with how to find the surface area of a prism. To find the total surface area of a prism, we've got a formula. It's pH plus 2b. Now, what do those letters mean? Well, the P is the perimeter of the base. So, for instance, on this prism here, maybe I choose this side to be my base. So the P would be the perimeter of that base, all four of those sides added together. The H, the lowercase h there, is the height of the prism. So in this case, it would be that. And then the B, the capital B, is the area of the base. So in this case, that would be how I would annotate it on my diagram. Now, rectangular prisms like the one that I've got in that picture can be a little bit more strange because you can choose any of the sides to be your base. But the height is always going to be the distance from base to base. If you want to find the lateral surface area, then it is just pH. So just perimeter of the base times the height. Now, depending on what shape your base is, that formula is going to kind of shift a little bit because, for instance, on the rectangular prism, to find the area of the base, you would just do the area formula for the rectangle. But if you have a triangular prism, like we're going to see, then you're going to have to do the triangle formula. So just keep that in mind, that B, you got to know your area formulas to find that B. So let's try these formulas out on a few of these here. So let's start with this rectangular prism here. So I'm going to do pH plus 2b. I'll say S equals, S for surface area. P will be the perimeter of the base. So if I was going to find the perimeter of this base here, what would I need to add up? This would be a 6, this would be a 5, this would be a 6, this would be a 5. So that would be 6 plus 5 plus 6 plus 5. So that is going to be 22. Now for my H would be this 4 here. And then for my B, I would need to find the area of the base, which, since this is a rectangular prism, I would do 5 times 6, which is 30. So all in all here, I'm going to do 22 times 4 plus 2 times 30. 22 times 4 plus 2 times 30. I'm going to get 148, and this would be centimeters squared. All right, let's try it out for our triangular prism here. Now, since my base on this one is a triangle, remember your base is your repeated side, your repeated parallel sides, congruent parallel sides. So my P here, I'm going to find the perimeter of this triangle. My H, my distance from triangle to triangle, would be this 12. And the B is going to be the area of the triangle. So let's try finding these here. My P this time, I need to do 8 plus 6 plus 10. That's going to be 24. My h we already said and found was 12. And for the area of the base, I need to do the area of the triangle. I think it's safe to say that that would be my right angle right there. So this is going to be 1/2 base times height, 1/2 8 times 6. Half of 48 is 24. So this is going to be 24 times 12 plus 2 times 24. So 24 times 12 plus 2 times 24 is, I'm getting 336 centimeters squared. Okay, so hopefully you guys can see how those formulas are going to change a little bit depending on what kind of prism you have. That capital B, you got to be on your toes. Depending on what shape the base is, you got to do a different area formula to find it. Moving on to a pyramid. So total surface area of a pyramid is 1/2 PL plus B. So we've seen capital P before. That is the perimeter of the base. Your L is the slant height. It is the distance from the vertex of the pyramid down to the midpoint of one of the sides of the pyramid. Then the B, once again, is the area of the base. For the lateral surface area, you just do the 1/2 PL. Because remember, lateral surface area is just the sides. It does not include the base. And we know what P and L stand for. Okay, so let's give these two a shot. They want us to do this total surface area formula. So 1/2 PL plus B. P is the perimeter of the base. This looks like it's a square pyramid. So our perimeter, our perimeter is just going to be 4 sets of 12, which is 48. Our L is the slant height, and they gave us that as 10. And then our B will be the area of the base, which since this is a square, we're just going to do 12 times 12 to get 144. So we need to do 1/2 times 48 times 10 plus 144. Let's see what happens there. 1/2 times 48 times 10 plus 144, getting 384. And that's centimeters squared. And then we've got a triangular prism, or I'm sorry, triangular pyramid here. So once again, we'll do 1/2 PL plus B. P is the perimeter, which it looks like that's a regular triangle down there. All the sides are 6. So we'll do 6 plus 6 plus 6, which is 18. For the L, looks like we got a slant height of 9 here. And then for the B, since this is a triangle, you do 1/2 base times height. Do 1/2 times 6 times, looks like the height of that triangle is that 5.2 they gave us. So 1/2 times 6 times 5.2 is 15.6. All right, so we got all of our information here. So we're going to do 1/2 times 18 times 9 plus 15.6. And that is going to be 96.6 centimeters squared. Very cool. All right, now those formulas there for the surface area of the pyramids, that does only work for regular pyramids. So the bases have to be equilateral, equiangular. So, you know, squares, equilateral triangles, that kind of stuff. If you have an irregular base, that formula is not going to work. Okay, so let's go to the inside here. Our next set of shapes are going to be some cylinders. Cylinders have some fun formulas. For the total surface area of a cylinder, you've got 2 pi RH plus 2 pi r squared. And for the lateral formula, it's only going to be that 2 pi RH part. So really, there's only two things you need to know for cylinders. You got to know your radius, which of course is the distance from the center of one of the circles out to the outer edge. And then you need to know your height. So only two things, pretty easy to do the cylinders. So let's give it a shot here. 2 pi RH plus 2 pi r squared. Looks like we got everything we need. Our r is 5. And our h is 10. So let's plug it all in there. We're going to do 2 times pi times 5 times 10 plus 2 times pi times 5 squared. 2 pi 5 times 10 plus 2 pi times 5 squared. I'm getting 471.2, going to just round to the nearest tenth on these, centimeters squared. Give it one more go here. 2 pi RH plus 2 pi r squared. Our height is 6. Our radius, we're not going to get confused here. Our radius is going to be 10, right? Not the whole 20. So let's plug it in. 2 pi 10 times 6 plus 2 pi 10 squared. Let me plug that into my calculator here. And I'm getting 1005.3 centimeters squared. And that is with me using the pi button on my calculator, not 3.14. So if you're trying it using 3.14, yours is going to be a little bit different than mine. All right, moving on to the cone here. For the cone formula, we are going to do, for the total surface area, it is pi RL plus pi r squared. And for the lateral formula, we're just doing pi RL because we don't want that pi r squared because we know that pi r squared is the circle on the bottom, right? So only a couple things we need to know on this one. We do need to know the slant height again, which is the distance from the vertex to the edge of the base. And we got to know the radius again, which is the distance from the center on out. So let's give these a shot here. Pi RL plus pi r squared. Looks like we've got everything we need. We know our slant height is 5. We know that our radius is 3. So we're just going to do pi times 3 times 5 plus pi times 3 squared. Pi times 3 times 5 plus pi times 3 squared. I'm getting 75.4 centimeters squared for this one. And then for our second one here, same idea, pi RL plus pi r squared. Our slant height is the 16. Our radius should be 8, since we're not going to use the diameter there. Radius is 8, slant height is 16. So this would be pi times 8 times 16 plus pi times 8 squared. Let me type that in. Let's see what we get. I'm getting 603.2 centimeters squared. Okay, only one last type of three-dimensional solid for our basic examples here. We do have the sphere. For the sphere formula, we've got 4 pi r squared. And there actually is no lateral surface area for a sphere, so we don't even need to write that one. For the radius here, of course, that is the distance from the center on out. So let's give it a shot. On this one, we should know that our radius is 4. So we do 4 pi r squared. We're going to do 4 times pi times 4 squared. And I'm getting 201.1 centimeters squared. And then on this one, no tricks at all. We just got to do 4 times pi times r squared. This is 4 times pi times 3 squared. And I'm getting 113.1 centimeters squared. Oh, I should still do my highlighting, shouldn't I? Always color code. Okay, so last little ones here. Time to get a little bit tricky now that we know the basics. This one says find the total surface area. This is definitely a cone. We can identify that. Cone total surface area formula was pi RL plus pi r squared. So our radius is 9. That's cool. But we actually don't have the slant height. What they gave us was the height of the cone, not the slant height of the cone. Now, fun fact is that the height, the radius, and the slant height do form a right triangle. So what we can do, first of all, is a little Pythagorean theorem here to find out what L is. We can do 9 squared plus 12 squared equals L squared. That'd be 81 plus 144 is equal to L squared. That's 225 is equal to L squared. So take the square root, we get 15. Some of you may have recognized that that is a Pythagorean triple, right? That is the 3, 4, 5 right triangle, just all multiplied by 3. So now we know what our L is. Now we can do pi times 9 times 15 plus pi times 9 squared. Let me type that into my calculator. And I'm getting 678.6 centimeters squared. Alrighty. Last one here says find the total surface area of this thing. What is this? This is a pretty wild shape. This is a hexagon. Oops, spelled that wrong. Hexagonal or hexagonal prism. Now, since it is a prism, we need to do the formula for a prism, which is pH plus 2b. Now, let's be careful about this one. This one's definitely the trickiest one we've seen. The P is the perimeter of the base. The H is the height of the prism, the distance from hexagon to hexagon, which should be that 2. And then the B is the area of the base, which would be the area of the hexagon. So let's take this step by step. Can we figure out what the P is? Not right now. We don't know what any of the sides of the hexagon are. We do know, so let me write down some stuff here. P, we don't know. H, we do know, that's 2. And B, the area of the hexagon, well, you know the formula for that. The formula for that is 1/2 AP. That's the formula for any sort of regular polygon. Now, as far as that formula goes, we do know what the apothem is. The apothem is that 4√3 they gave us. But the P, we still don't know because that's the same P that we didn't know from before. So that's really our hang up. If we can figure out the perimeter of this thing, then we're in business. Now, hopefully some of you all watched the video where we talked about area, and you remembered that to find this little angle up there formed by the radius and the apothem, we can do the formula 360 divided by 2n, where n's the number of sides. There's 6 sides on the hexagon, so we do 360 divided by 2 times 6, and we get 30. This is a little 30-degree angle up there, which means that that little triangle is a 30, 60, 90 triangle. And for 30, 60, 90 triangles, if we want to find the short leg of it, this part right here, we can take the long leg, which is the 4√3, and divide it by √3. 4√3 divided by √3 is 4. So this little part right there is 4, which means that this little part over here is also 4, which means that one side of our hexagon is 8. So our perimeter then becomes 6 times 8, which is 48. And then if our perimeter is 48, then we can also plug that into our area formula. And 1/2 times 4√3 times 48. I'm just going to multiply everything other than the √3 here. 1/2 times 4√3, or just times 4, times 48 is 96. So the area of the base is 96√3. Okay, now I will plug everything into our surface area formula, and I should be able to find my answer here. Now for that one, I am going to round to the nearest 10. So 48 times 2 plus 2 times 96√3. So I'm just typing all this in this time. I like to not round until the very end if I don't have to. 2 times 96√3. I'm getting 428.6 centimeters squared. Okay, that was a good one. So that is a perfect example of how, depending on the type of prism or the type of pyramid, you might have to do a little bit more work to find that area of the base. Okay, so it is your turn to shine here. You've got 6 examples, 6 surface areas to try to find. Give those a shot and then come on back when you're ready to check to see how you all did. I will warn you that the very last one you do have to do the Pythagorean theorem on. All right, so for this first one, this was a cone. Should have done pi RL plus pi r squared. That should have been pi 5 13 plus pi 5 squared. Let me see what I get here. I got 282.7 centimeters squared. Then we had a cylinder. Cylinder was 2 pi RH plus 2 pi r squared. This should have been 2 pi 7 times 4 plus 2 pi 7 squared. And as I plug that in, I get 483.8 centimeters squared. For our rectangular prism here, we got to do pH plus 2b. Our perimeter, if you chose like this side as your base for the perimeter part, you should have gotten 3 plus 6 plus 3 plus 6, which was 18. Your height then should have been 6. Oh wait, no, I'm crazy. It should have been 3 plus 7 plus 3 plus 7. Which is 20. Then your height is 6. And then your area of the base is 3 times 7, which is 21. So we should be doing 20 times 6 plus 2 times 21, which is 162 centimeters squared. For our pyramid here, we need to do 1/2 PL plus B. Your perimeter should have been the perimeter of the square down there, which would have been 4 times 8, which is 32. Your L is 7, and your base should have been 8 times 8, which was 64. So we're going to do 1/2 times 32 times 7 plus 64. And I'm going to get 176 centimeters squared. For the sphere, we just need to do 4 pi r squared, which should just be 4 times pi times 5 squared, which gives me 314.2 centimeters squared. And then we got our last one. This is a prism, triangular prism to be exact. So we need to do pH plus 2b. For the perimeter, we need to do the perimeter of this triangle here. And I don't know what this side is, the hypotenuse. Now, if you did do the Pythagorean theorem, hopefully you didn't. Hopefully you recognized that it was a Pythagorean triple, but if you did, got 3 squared plus 4 squared equals x squared. That's 9 plus 16. That's 25. So when you take the square root, you found out that that side was 5. So your perimeter should have been 3 plus 4 plus 5. That's 12. The height of the prism was the 6. And the area of the base was 1/2 base times height, 3 times 4, which was 6. So all in all, we should have done 12, which was the perimeter. Yeah, 12 was the perimeter times the height, which was 6, plus 2 times the area of the base, which was 6. And we get, I think that's 84. Yeah, 84. And there you have it. Hopefully that went well, and that's going to wrap up this video.